This is actually a really cool question, but just for reference, it is a web work question. And for the fall of 2014, at least I'm not planning on putting a question like this, exactly like this, on the exam. Although the same concepts can come up in any calculus class, but the exact structure of the question was as a web work thing. Okay, so the way it works is there's three functions, a, b, and c, conveniently red and blue and green. And the way this question works is you're trying to find one is the original function, one is the first derivative, and one is the second derivative. So there's this relationship between them. And some students found this really obvious, and some found it really, really hard. So if you find this obvious, then you don't have to go through all this mess to get to the answer. But in case you're one of the people who found it harder, or think that this is a harder question, then I just came up with this methodical way of eliminating any wrong possibilities, and then the only thing that remains is the possibility that's correct. Okay, so you start off with the knowledge in the beginning that there is some relationship, and this is f prime, and f double prime, but you don't know which is which. Okay, so without that information, you can't eliminate wrong possibilities. Okay, so what you want to do is it possible for the following? Can a prime equal b? Can a prime equal c? Can b prime equal a? Can b prime equal c? Can c prime equal a? And can c prime equal b? So 2 of these relationships have to be true, and 4 of these relationships have to be false. So I'm just writing all these down. I wrote them, I typed them up, but we're just doing the same thing, but I just made a shorthand off to the left. And I'm going to go through, and when you go through, you should be able to find the 4 false ones and rationales for why they're false, and then what remains has to be true. So even though they're asked in chronological order, you answer them in whatever order you can. Right? So for example, the first one is true. Yes, it's actually let me answer this one. This one is going to end up being true, and the other one is a prime equals c is this one is going to be true. Not the one I checked, sorry. Like that. Those 2 are going to be true, but we don't know that. So let's look at the possible things that are going on. First of all, we see that b has no zeros. Okay, so b cannot be the derivative of a or of c. Okay, so you note b prime is equal to 0, never, 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 never. So actually you already know that it has to be the original function, but let's not assume that. Let's be a little more methodical and say this shows that b cannot be the derivative of a and cannot be the derivative of c. Okay, so c prime equals b is no, b prime is not equal to 0 ever, and a prime cannot equal b for the same reason. B prime is not equal to 0 ever. Okay, so this tells you already who the original function is, but we pretend we don't know that. Let's ask about the relationship. Pretend like b wasn't even part of the problem. A and c. A and c has some kind of relationship. So I look at this green function, this function which is green. It's not a greens function, but it's a green function. Okay, so right here, there's a derivative that's 0. So c prime of 0 has to equal 0. Well, look at a of 0 equals 0. Well, this is lovely. So c prime could equal a is possible. So it's a very strong possibility, and I'm going to make a note, possible here, and I'm going to say, look, it can't be the other way around because why? Well, actually, so far it's possible, right? Just based on what I circled, it's not impossible, because look what happens. A prime, so a prime equals c is possible too, and one of these is going to be impossible. Based on what we just did, so far this is possible. So like, that's too bad. They can't both be true. So let's come up with some more clues here. One of these can't be true. All right. Let's find a counterexample so that one of them is impossible. Let's see. So what I'm doing is I'm looking at every case, I'm looking to see if the derivative of the green curve is the blue curve. Well, that's true, and the derivative of the green curve could be the blue curve, and actually they interlace pretty nicely, so that's not going to help us. So we're going to have to look at something else that's going on here. Let's look at the fact that here this blue curve is strictly increasing and the green curve is positive. Then when it's decreasing it's negative, when it's increasing it's positive. Okay, well, let's see if we can get the same relationship going the other way. So at this point we're thinking A prime might equal to C by investigating what's happening with increasing and decreasing of blue. Well, what about increasing and decreasing of green? Okay, so for example, green is decreasing. C decreases from -3 to, I don't know, -1.5. So its derivative has to be strictly negative, but unfortunately the blue curve is positive, right? So it's in the wrong direction. So you would say C prime decreases from -3 to -1.5, but actually B and A are both positive, so we get 2 for the price of 1. So neither B nor A can be C prime. Okay, so let's get rid of these jottings. So that eliminates that. Okay, so neither B nor A can be equal to C prime, so this is not possible. And we also got rid of, well, we already knew this was impossible. Okay, so we just have to figure out if B prime is A or C, right? So let's figure this out. So let's see. B prime. B prime is, well, let's see. B is increasing. Gotta use a different color. B is increasing over here, and so you expect something to be positive. Well, we need something to be positive and then negative. This is negative, and I guess this is positive. I think B prime is A. Let's just make sure. It's probably easier, it's almost always easier to prove something that is false in this setting. So B prime is not equal to C because, so let's try to figure out why. Let's find a counterexample. Alright, so let's say right here. Yeah, there we go. That's a great example. -2 at x equals -2, B prime is positive, but C is negative. Great, we found a counterexample. So this one is not possible. So this one is possible. Okay. So you see, we hit some issues and we kept going. Sometimes we got some inconclusive leads, and you know, this is okay. You know, so we take these rationales instead of scribbling them down on the side. I can just say, okay, why are these true? B prime is not equal to 0 ever. So is it possible for B to be the derivative of A? No, because B prime is not equal to 0 ever. Is it possible for the derivative of C to be B? No, B prime is not equal to 0 ever. And then these same rationales on the right hand side can be copied in. You can say, well, B prime is not equal to C. So what the way we say B prime is not equal to C, C is not the derivative of B. No, because at x equals -2, B prime is positive, but C is negative. And is it possible, what was the other one? Be the derivative of C. This is no, because C prime decreases from -3 to -1.5, but A is positive. I meant to say C decreases. Whoops. I meant to say C prime is negative. Okay. All right, so then the only ones that are remaining that have to be true, and this is the point I want to point out, is that the two yes answers are the very last thing that you say, and then you can conclude, aha. So is it possible for A to be the derivative of B? Yes. Is it possible for C to be the derivative of A? Yes. And now it says, for the functions there is a relationship, and then you would have to figure out the f. Okay, if A is the derivative of B, but C is the derivative of A, C is, you know, this little piece is a little bit difficult. You got to figure out which way it goes, right? And what ends up happening is it only works if you start with B, right? If you take B prime, F prime is B prime, which is A, right? And then F double prime must be A prime, which is C. So maybe that's a better way of thinking of it. So F prime, F double prime, B, A, C. Okay? So it's a little bit of a lengthy explanation, but again, this was something that was a homework problem for the students who had this question on their exam. So they had seen this structure before, and we had actually talked about it in class. So I hope that you feel enlightened, even though it is a challenging question, and hopefully you